Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on factorization for mathematics grade 9. And this is part 4 of a 4-part video series. And in this part, we're going to focus on how to factorize the trinomial, all types of trinomials. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on more videos we upload in the future. Now back to the video. In summary, we're going to focus on number 1, trinomials of the form x squared plus bx plus c, and you see exactly what type I'm talking about. Number 2, we're going to look at trinomials of the form ax squared plus bx plus c. What if there is a number besides 1 in front of x squared? In fact, in other words, if the coefficient of x squared is anything else other than just 1, it could be 2, could be 3, could be any number. Number 3, we're going to look at trinomials of the form x squared minus bx plus c. Now notice we're not having pluses all together anymore. There is a minus in the middle. How do you deal with trinomials like that when you need to factorize? Number 4, we're going to look at trinomials of the form ax squared minus bx plus c, where your coefficient of x squared is not 1. However, the middle term is still negative. Number 5, we're going to look at trinomials of the form x squared minus bx minus c, where all the signs in that trinomial are negative. How do you factorize that? We also are going to look at number 6, trinomials of the form ax squared minus bx minus c, where the coefficient of x squared is not 1 and you have minuses separating your trinomial. We have a lot to cover, so let's start. First of all, let's recap on what factorization is. Remember, factorization is the reverse of multiplication. When you have a binomial, right, on the left hand side, and you multiply that binomial using whatever method you want to use, preferably FOIL, first, outer, inner, last, the method. If you multiply this, it will give you what is on the right hand side. This process from the left to the right is what we call multiplication, and the process from the product back to the factors is called factorization. So factorization is basically you taking the product which was multiplied and all was added together and everything, and you break it down back into its factors. In other words, what we multiply together in order to get that product. Now, before we go anyway, let me prove to you that this indeed gives you this. All right, on the left hand side, we are going to multiply x plus 3 times x plus 2. Both of these are binomials. Binomial in algebraic expression with 2 terms. So when you use the method of FOIL, FOIL, first, outer, inner, last, this is what you get. That will be equals to, first of all, you multiply the first times x gives you x squared. Next, x times 2 gives you 2x. And then next, 3 times x, which is the inner, gives you 3x. And then lastly, 3 times 2, that gives you positive 6. Now you add the middle terms because these terms are like terms and we add like terms. So this is 2 cows plus 3 cows, that will give us 5 cows, and the answer therefore is x squared plus 5x plus 6. Now that I've convinced you, when you multiply the left hand side together, you get the right hand side. Now let me show you how we go back from this back to the factors. In other words, how to factorize. We're going to take this process step by step because factorizing a trinomial can be a little complicated. You need to understand that you've got different types of trinomials. Now, the first type of trinomial we're going to look at is trinomials of the form x squared plus bx plus c. In other words, the coefficient of x squared is 1 and you've got pluses all over the place. And this type is going to be specifically the square of a binomial. Remember, when you squared a binomial, right, when you were multiplying out, when you square a binomial, basically, you multiply a binomial by itself, right, and that gives you this type of answer. x squared plus 2ax plus a squared. Let me show you here. When we multiply this binomial, x plus a all squared, that is equals to, in bracket, x plus a times x plus a. That's what the exponent there means. It means that you multiply this x plus a by itself twice. So using the method of FOIL, this is what we end up with. The first are x times x, and that gives us x squared. Next, the outer are x times a, that gives us ax. And now next, the inner is a times x, that also gives us ax. And then the last terms become a times a, and that gives us a squared. The terms in the middle are like, so we add them together. That will be x squared plus 2ax, because it's a cow plus a cow. So that is 2 cows. And that's what you get, x squared plus 2ax plus a squared. Now notice this pattern is common for all types of binomials that you are squaring. When you square a binomial, you're basically multiplying that binomial by itself twice, which is what we did with this one. Now, this is also what we call the square of a binomial. Don't believe me? Let me show you. X squared plus 2x, we get that x squared plus 2x plus 1. This is gotten by when we multiply x plus 1 all squared, which gives us x plus 1 times x plus 1, which then gives us, using FOIL, x times x, that is x squared. Next, x times 1, that is plus x. Next, it's 1 times x, that is x. And then the last one is 1 times 1, and that gives us 1. Now, when we add the like terms in the middle, a cow plus a cow, that gives us 2 cows. So that is x plus x is equals to 2x. And that gives us x squared plus 2x plus 1. This is what we call an answer you get, or a product you get when you square a binomial. Now, how do we factorize this? Notice that when you're dealing with a product of a square of a binomial, is that you will have x plus the square root, all right, of the square at the top, at the end, times x plus the square root. So what is this? 1 can be written as 1 times 1, which is equals to 1 squared. Therefore, the square root of 1 will be 1. So what we do here is that we, step number 1, write 2 pairs of brackets, and then in the first ones we write x and then xy, because when we multiply the x's together, which is what we do when we use FOIL, the first terms will give us x squared. Now, step number 2 is you go to the last term. In the last term, you go 1 times 1. These are the factors of 1. That's what you do on the last term. The factors of 1 give us 1 and 1, so meaning that these are the terms that we're going to put here, and then all you do is you put pluses. Now let's check. Right, if you multiply this out, you add 1 and 1 together to get the middle term. In other words, you add the last terms together to get the middle term, and that's how you factorize. Let's look at another example. More of this type of examples. Here are more products that come from squares of binomials. But even if you didn't notice that these were coming from squares of binomials, when you factorize the first step, when you factorize a trinomial, first step is you write 2 pairs of brackets, and then in each bracket you go x, and the other one you go x. And then step number 2 is you find factor pairs of the last term. The factor pairs of 4 are 4 times 1 and 2 times 2. Now, if you add 4 and 1, 4 plus 1 will give you 5. And then if you add 2 and 2, that will give you 4. The correct combination, therefore, that you choose is 2 times 2, because when you add them together, which is how we get the middle term, we add the terms. the last terms. If you add them together, they'll give you 4. So that is the combination we choose, because that is the combination that when we multiply together, 2 times 2 gives us the last term, which checks out. And when we add them together, 2 plus 2 gives us the middle term, and that checks out. And the x squared was checked out when we multiplied the first of each bracket. Same story over here. We go, that is equals to, and then 2 pairs of brackets, x in each first bracket, and now we find the vector pairs of 9. 9 times 1 and 3 times 3. Make sure that you list them all in order, because you don't want to miss a vector pair that could end up being the answer to your problem. Now the first term, the first pair gives us 10. 9 plus 1 equals to 10. And the second pair gives us 3 plus 3 equals to 6. We are looking for the pair that when we add together gives us 6. And that pair is 3 times 3. So this is the vector pair that we choose. And then you put pluses, because you only have pluses. You don't have to worry about the minuses now. We're going to take a look at that later. Same story you can do for this one. Now I want you to take a screenshot or pause the video and complete these 2 sums and see if you can get the right answer. To check if you got the right answer, multiply it all out using FOIL and how to multiply a binomial by a binomial, and that will show you whether you've got the right answer or not. You'll be able to check your answer right. Now let's move on. Now let's look at the second type of trinomial that you get. That's when you get just the product of any 2 binomials, like we did with that x plus 3 times x plus 2. This question, x plus 3 times x plus 2. That is just a normal binomial by another binomial. It's not a special one that you get when you square a binomial like we did with the one that we just looked at. Now, I want you to notice something when it comes to these binomials. All of them start with x squared. All of them have got pluses, no minus. That's number 2. And then number 3, all of them have got 72 at the end as your last term. Now I want to show you something, a secret that you probably don't know. And the secret is that all of these combinations, when you find the vector pair of 72, you will be able to get all these types of combinations. All you do to get different middle terms is that you just use a different vector pair to find the answer to your question. Now, the first thing we do here is we're going to find all the vector pairs of 72. That we're going to look at all the vector pairs of 72. The first one is 72 times 1. The second one you get by simply going 72 divided by 3, by 2, sorry. And that will give you 36. So there is none. So you write 36 times 2. Notice that I'm writing the big ones from the left will go down as we go, and then the smaller ones on the right hand side will grow as we go. Next, we find what 72 divided by 3 is, so we can find that vector pair. That gives us 24. So that is 24 times 3. That's what you write, 24 times 3. And now you go 72 divided by 4, that gives us 18. So that will be 18 times 4. Next, let's try 5. 72 divided by 5. It doesn't give us a whole number, so if it gives you a fraction, skip it. You don't use it. 72 divided by 6, that gives us 12. So that will be 12 times 6. Next, let's try 7. Gives us a fraction. Let's try 8. That's 8 times 9, or 9 times 8. Notice that the 9 times 8 is the last vector pair, because after that you basically just go coming back up. right, rewriting this all that we've written. Now notice we've got a total of 2, 4, 6 pair combinations, and you will see depending on what combination we use, we will be able to get the correct answer for each one of these binomials, trinomials that we need to factorize. Let's start with the first one. All right, all of them will have 2 pairs of brackets and then with an x and an x. Now the factor pair combinations we use for each one will depend on what the middle term is. Now to get this middle term, notice that this factor pair is the correct one to choose because 72 plus 1 gives us 73. Now 36 plus 2 gives us 38. 24 plus 3 gives us 27. 18 plus 4 gives us 22. 12 plus 6 gives us 18. And then 9 times plus 8. 9 plus 8 gives us 17. 17. So we've got 17, we've got 18. All right, let's start. Now with this one, we need the factor pair combination that when added together gives us 73, and that combination is 72 and 1. Notice you don't have to write 72 on the right hand side. You can write it on the left hand side and switch the numbers around. You will still get exactly the same answer, no problems, no sweat. Now for the second one, we need a factor pair combination that adds to 38. This is the factor pair combination, 36 times 2. So that will be 2 pairs of brackets, x and x. And then we write 36 and 2. 36, 2, and then plus and plus. That will give us the correct answer for this factorization. Next, same factor pairs, same factors, right? But we need one that will give us 27, and this is the 24 times 3, 24 and 3. So that is x and x. And then we'll write 24 in one bracket, and then 3 in another bracket, and that gives us the answer to that question. Next, we must get the factor combination that must give us 22 in the middle, and the correct one is 18 and 4. 18 and 4, and that is plus plus. Next, we need 18 in the middle, so we must use this combination 12 times 6 because that's what will give us the correct answer there. X and x, 6 and 12, plus and plus. Lastly, this one has 11 in the middle. Is it 11 or 17? Yeah, it should be 11, not 17, sorry. Yeah, it should be 17, not 11. Yeah, sorry about that. This was supposed to be 17. Let me fix that. Let me fix the 17. Okay, sorry about that. All right, the last factor pair we have here is 9 and 8. That will give us 18. I mean 17. If you add 9 to 8, it will give us 17. So that is x and x, and then 9 and 8. And then we've got pluses in the middle. And that's how you basically factorize the product of any two binomials, right? A trinomial that is basically gotten from just the product of any two binomials, and you've got pluses. Next, let's look at trinomials of the form ax squared plus bx plus c. What happens when the coefficient of your x squared or y squared in this case is not 1 but 2 or some other number? You check if you can take out a common factor first. So we take out that common factor here, and the common factor that we have for 2, 10, and 8 is 2. So that leaves us with y squared plus 5y plus 4. Just double check. When you multiply out, you should get back to the original. Now what you do is you leave the common factor outside and then factorize this trinomial like you would if you didn't have to take out any common factor. So that will be y and y. And then we look at factor pairs for 4 this time. That will be 4 times 1 and 2 times 2. We're looking for the combination that will give us 5 when we add them together. 4 plus 1 is the one that gives us 5. And then 2 plus 2 gives us 4. So the correct combination that we must use is 4 and 1. So we use 4 in one and 1 in the other. And that's how you do it. Next, let's look at the next scenario. Trinomials of the form x squared minus bx plus c. What happens when you've got a minus in the middle and a plus on the outside? Now this one looks difficult, but it's actually very easy, and this is how you approach this. Step number 1, 2 pairs of brackets and then the k in one and then k in the other one. Now we go factor pairs of 27. We must list them all. 27 times 1 and then we've got 9 times 3. These are the only 2 factor pairs. Now we must find the factor pair combination that can give us 12 one way or the other. Notice that we've got a negative and a positive, a negative in the middle and a positive on the outside. Now whenever you have a situation like this, understand that the last term will be positive 2 ways. Either it's when you multiply a positive or a negative by a negative. Now if we were to multiply a positive by a positive to find the positive, we would have a problem in the middle because we have a negative. So the pair combination of the signs that is best whenever you have a minus in the middle and a plus on the outside is to use this pair. Negative times negative. So that's what we're going to use. And now what you do is you find a factor pair combination that can give you 12 between the two. Let's start. 9 plus 3 gives us 12. Yes. And then we've got 27 plus 1. That gives us 28. So this one is not the correct one, right? The correct one is 9 times 3. So we put 9 and then 3. Check. Negative 9 minus 3 gives you negative 12. So yes, it checks out. And that's how you factorize that. Same story over here. Well, different story over here. Notice that you still have a plus 27, right? But you have a negative 28 in the middle. The factor pair combinations for 27 haven't changed. It's 27 and 1 and 9 times 3. 27 times 1, 9 times 3. Which one then do we choose? Notice that this one, 27 and 1, when you add them together give you 28, but 9 and 3 give you 12. So the factor pair combination that is perfect for this one is the other one, which is 27 and 1. And that's how you can have so many different combinations of the same last term, but end up with different middle terms because of how you pick the combination that works best for you. Remember, the signs must be negative. Multiply this one out, all of them, just to check using FOIL to satisfy yourself that this is the correct answer. Next, let's look at trinomials of the form ax squared minus bx plus c. Same story as with the other two we looked at. All right. Check if you have a common factor. The common factor between 3, 15, and 12 is 3. And that will leave you with x squared minus 5x plus 4. And the trinomial that you factorize is this one in the brackets, inside the brackets. So now we've got x and x. Now 4 times 1, so we're looking for factor pair combinations of 4 now. 4 times 1. Okay, 4 plus 1 will give us 5. 2 plus 2 will give us 4. So the factor per combination that gives us the 5 in the middle will be 4 and 1. And we have minuses, because when we multiply the minuses together, they'll give us a positive, but when we add them, they will give us a negative. Don't believe me? Let's look at this. Negative 1 times negative 4. Negative times negative equals to positive. Negative times negative is positive. 1 times 4 is 4, and that checks out. But also, when you add these two together, negative 1 plus negative 4, you can take out a calculator if you don't believe me. That will give you negative 5. Negative 1, negative 1, okay, negative 1 plus negative 4. That gives you negative 5. There we go. So it gives you negative 5, and that checks out. So this is the correct answer. Number 5, let's look at trinomials of the form x squared minus bx minus c. This one has got minuses all over the place. Same story. We must have 2 pairs of brackets. Then we will have y and y. But notice that this is then what happens. Let's find the factor pairs of 27. 27 times 1 and 9 times 3. Now this one, you need to be very careful here. You need to find the factor pair combinations, right? That will give you 6 in the middle, negative 6, and still give you 27. Which one is that? So also notice that the last term is negative. The only way you can get 2 terms when multiplied together, which is how we get the last term, to give you a negative, is if one is positive and the other one is negative. So already we know we're going to have a positive and a negative. All right. Question is, where do we put what way? Okay, first of all, let's go back and choose the factor pair combination that we need in order to give us 6. So now notice, if you add this to 27 plus 1, they give you 28. When you subtract 27 minus 1, it gives you 26. All right. The second combination, when you add 9 plus 3, it gives us 12. And when you subtract 9 minus 3, it gives us 6. So the combination that will give us 6 is the last one, 9 and 3. Because when you subtract, you get 6. So we'll have a 9 in one and a 3 in the other. Now question is, where do we put the plus and where do we put the minus? We put to make that decision, we look at what sign we have in the middle term. If the sign in the middle is negative, then what happens is that we put the negative in front of the bigger term. There we go. Let's multiply this out. So y times y, that will be y squared. Y times negative 9, that's negative 9y. 3 times y, that is 3y. 3 times negative 9, so that is negative 27. The negative 27 and the y squared are taken care of. Negative 9 plus 3 is negative 6, so that checks out. This is the correct answer. Now the last slide is when you have something else besides 1 in front of x squared. Always check out if you can take out a common factor. The most common factor here is 2. That leaves us with x squared minus 4x. And over here, let's divide 154 by 2 to see what we get. If we divide this by 2, that gives us 77. So that is what then we get, negative 77. And what we do now is we factorize the trinomial inside the bracket. So we've got x and x, and then 77 times 1, and then we've got 11 times 7. Those are the two factor pairs we have. All right, the combination that can give us 4, let's see. 77 plus 1 equals to 78. Now let's look at what happens when we subtract. 77 minus 1 gives us 76. All right. And then the other factor pair, 11 plus 7 gives us 18. Then 11 minus 7 gives us 11 minus 7. Okay, take out a calculator. 11 minus 7, that gives us 4. So the combination that gives us 4 is the 11 and 7. That's the one we pick. 11 and 7 is the one that gives us the combination. That's the one we pick. 11 then 7. Question is, where do we put the plus and where do we put the minus? The sign in the middle is negative, so that means we must put the minus in front of the bigger term, which is negative 11. And that's how we factorize. We've come to the end of this video. Thank you so much for watching. I'll see you in the next one. Bye bye.